Close your eyes for a second. Imagine you are standing in total darkness, deep inside a cave. Thousands of years ago, the only light comes from a small torch in your hand. The walls are cold. The air is silent. And then, something catches your eye. A single reflection, glowing softly in the dark. Not gray, not silver, not stone. Pure, warm, golden light staring back at you. That one moment changed the entire course of human history. Think about it. Every metal around you looks the same. Iron, steel, aluminum, titanium. They all share the same cold, lifeless silver color. Walk into any workshop, any factory, any mine, and everything around you is just gray. But then there's gold. And there's copper. And from the very first second you see them, you know they're different. Ancient Egyptians didn't just like gold. They believed it was literally the flesh of their gods. Roman emperors didn't just collect it. They thought it held the secret to immortality. Entire civilizations rose and collapsed chasing this one glowing metal. But nobody stopped to ask the real question. Why does it glow like that? Why does nature give color to only these two metals and leave everything else silver? The answer is hiding somewhere you would never expect. Inside atoms, invisible, tiny, silent. And it involves one of the most powerful ideas in all of science. Here's what's actually happening inside a piece of gold. Every metal has electrons. Tiny particles spinning around the center of each atom when light hits a metal surface. These electrons absorb some colors and reflect others. Most metals absorb and reflect every color equally. So when white light hits them, all colors bounce back together, and your eye sees silver. Simple, predictable, boring. But gold is not simple. Gold atoms are incredibly heavy. And that heaviness creates something almost unbelievable. The electrons inside gold, they don't just move fast. They move so fast that something extraordinary begins to happen. Something that normally only matters near black holes. Something that reshapes the very fabric of space and time. Einstein's theory of relativity kicks in. Inside a tiny gold atom, electrons begin moving close to the speed of light. And when that happens, relativity changes their energy levels, shifts them, just slightly, just enough. And suddenly, gold starts absorbing blue light. Blue disappears. And what's left reflected back to your eyes is warm, golden, glowing. Sit with that for a second. The reason your wedding ring looks the way it does is because of the same physics that governs black holes. Without relativity, without Einstein's equations, gold would look exactly like every other metal. Cold. Silver. Forgettable. Copper tells a slightly different story. Softer, quieter, but just as beautiful. Copper's electrons absorb blue wavelengths too, but in a different way. What reflects back is warmer, more orange, more red. And copper doesn't stay still over time. It breathes, it reacts, it slowly transforms. That deep, weathered green, that wasn't always there. When the Statue of Liberty first stood, she wasn't green. She was bright copper brown. But year after year, the air touched her surface. Rain fell, wine passed, and slowly, a layer formed, a natural transformation called patina. Most metals never do this. Silver just stays silver. Aluminum just stays aluminum. But gold and copper, scientists sometimes call them the colorful rebels of the periodic table. They refuse to follow the rules. In a world of gray rocks and silver metals, a piece of glowing gold looked like it didn't belong here. It looked like it had fallen from somewhere else. And in a way, it had. Gold wasn't made on Earth. Not even close. Scientists believe most of the gold in the universe was forged during neutron star collisions, two dying stars crashing into each other, in that single catastrophic moment. Heavy elements like gold were born and scattered across the cosmos, so the next time you hold a piece of gold in your hand, you're not just holding metal, you're holding the echo of an explosion. You're holding relativity, chemistry, ancient human obsession, and the quiet violence of colliding stars. If physics had been slightly different, gold would be silver, ordinary, ignored. No pharaohs building tombs filled with it. So tell me honestly, do you think gold would still carry the same meaning? If it looked exactly like iron? Leave your answer below. And if this kind of storytelling speaks to you, subscribe to the History Flash.